So if you've taken a science class previously, you've probably heard of what we call the scientific method. The scientific method is how we carry out any work in any field of science. And the scientific method is a method that has, one really important principle. So if we wanted a definition of it, we can say that it's a systematic method that we can use for testing anything. So we talk about it in the context of science, but any theory that you have, you can test in this way. So it's for testing or for studying any process. And the key here is that it's based on reproducibility. In other words, being able to get a result that supports your theory once isn't enough to say that we can support that theory. We need to be able to show it over and over and over again in order for that to become valid. So how does this work, if we're talking about an actual experiment? Well, we have a few basic steps. And we often start with an observation. So something that we've noticed, something that we've seen, something that seems to work in a certain way. And it could be something that we've noticed, or it could be something that we found from doing experiments. But regardless of whether it was an experiment we initiated or we're looking at an experiment someone else did, some sort of task had to be performed. Once that's done, or as that's being done, we start to collect data. How much data? All depends on what we're studying. Sometimes, doing an experiment 2 or 3 times might be enough. Sometimes if we're doing a survey of people, we might need to talk to a couple thousand people. But we're going to collect data in some way. That data is going to allow us to form a hypothesis. So this is going to be our statement that we make that says, here's what the data means. Now, just because we've got some data that supports our hypothesis doesn't mean we're done. We're going to continue to test our hypothesis and see if we can gather even more data for it. And from those results, one of two things can happen. We continue to support our hypothesis, or the new data we collect doesn't support the hypothesis. If it doesn't support our hypothesis, then we have to either discard our hypothesis entirely, or maybe we find that we're close, so we just have to revise it. Over time, though, if we can gain enough support for it, that's when our hypothesis, turns into what we call a theory. And theory, unfortunately, is one of those words that has become one of the most misused words that we have in society. How many times do you hear about something and people say it's just a theory. And when we hear that, it's from people who either typically don't understand how scientists use the definition, the word theory, or are intentionally misusing how we use the word theory. So what is a theory? A theory is the best explanation that we have based on all current evidence. And because of the way we define this term theory, the way we define how we do science, brings us to our challenge. By definition, a theory can never be 100% proven. With additional testing, we can do one of three things. We can support it, we can modify it, or we can disprove it. But a theory is something that can never be 100% proven. And that's where we get this confusion, or in some cases just misleading thing that we hear in public all the time, that something's just a theory and that you can't prove it. And that might be true based on the way we define science. We can't prove a theory, but some theories we can confidently say the amount of evidence for them is so overwhelming that we will never see them disproven.